This goes over, I guess. But soon you be those fingers. You can't put them on now, you know. Those men doesn't.
I see you got the price on it.
That's getting long up here too. Add in the bottom truss, that'd be cool.
You can almost do like, what's that, Japanese style?
Man does.
So we cut the top and then leave the back
Yeah.
super long.
You should get connected. Yeah, next year.
Or what are the monks who just shave the top and then have like
The side.
the side
Top
tonsure? Isn't that what it's
Yeah.
called? There's some really styling ways for guys to have long hair.
A reverse mohawk, just a line down the middle.
The girl one?
Oh, I would.
Yeah.
With the ultra pointy goatee.
Like, that'd be cool.
You have that, like, white, so.
Yeah. You got a light. that'd be sick. Everybody can do that. Oh.
This is all you do.
Okay. Can you guys online hear us?
Yep.
Okay. Great.
So do I need to go in and put present for every class?
Yes.
Hey.
Okay, all right, Sam. Thanks for letting me know.
I have not opened it.
I don't know what he's doing. He's probably not doing the Moodle attendance since he just got into Moodle.
Yeah.
Okay, so just so you guys know, this semester I'm trying something different with attendance. You can mark your own attendance. There were some issues last semester where some people would show up late and I would forget to change their attendance from absent to late and they missed points. So if you have an electronic device, you can go in and mark it yourself. If you don't have an electronic device, just let me know. I need to mark your attendance. And I'm happy to do so.
Let's see.
But this way, my mistakes don't cost anybody points because that's not fair.
Is it on Moodle?
It is on Moodle.
All right, where do we start?
Okay, so I will show this and I will share the screen for everybody.
My last one took it so easily and this one.
We made it.
Okay, so if you go right here in the front page of the Moodle, there's this attendance widget. And if you click that, it will show you all of the sessions for the week. I have mine set up for the week. You can set it up where you see all of them, or for the month, or just for today. Mine are on weeks. So you click this little play button, and then on yours, it'll probably only show you an option for you to select attendance. I have everybody's, because I've got the power on Moodle.
Do we have to wait till 12 to do it, because it's not letting us do it?
Yeah.
It might.
That's
It might have to do that because that's what time the class is set to start.
Can you click the P on that?
Yes. P is present. O is online. You can only select present or online, I think within 5 minutes of it opening, and then it defaults to late. And if you don't select anything, it says you were absent. And then you guys can't click excused, but if you need an excused absence, that's what I do for your attendance. If you have an excused absence, it doesn't count against you for your attendance. But you, I think, have to wait 1 more minute for it to let you do it.
That we didn't get extra credit for being early.
No. So when the registrar sets a time, like 12 to 12:50, that automatically ports into Moodle. So I don't actually control the start time.
Not that far. So I have 10 classes next semester. That's it? Yeah, I have 4 pieces.
That's it.
Jenny.
Oh, no, I do.
Oh, there
Now
you
it's
go.
1 o'clock officially.
Okay, try now.
Submit
uh,
attendance.
Looks good.
Looks good. I am late.
There we go.
Well, that was magnificent.
We marked mine as well.
Yes, I can do yours, Kyle. You're here.
Yes.
Let's see. Did everyone think they get theirs?
It says on here, did it go through?
Yep, Cattell, you're here. So Wiley and Rodney. No, the O is just online. None of them are late. So Wiley or Rodney, are you guys online? Okay. All right. So that will be how we do attendance in each class. Yeah. Hey, I was just explaining. You guys are recording your own attendance. So when you go into Moodle, that little attendance, you can do it on your phone or your laptop or whatever. You'll click over here. There'll be an arrow like this, and then you can select your attendance, present, online, or late. If you don't have an electronic device and you want me to do your attendance, just remind me. But we had some people that I would mark them absent, and then they'd show up, and I'd forget to switch it, and they'd lose attendance points. This way you guys can just do that yourself. But since it's open, would you like me to mark your attendance? Okay. There we go. All right, and then last semester we had some issues with the messenger feature on Moodle. I would send some messages and some people wouldn't get them at all, or they wouldn't get them until much later, or some of you would get the message on Moodle, but it wouldn't send you an email letting you know there was a message. So I'm just going to use this announcements feature instead of sending the messages. Christy and I have tested it a few times, and she and I have always gotten emails when we post something. So right now, there's the course COVID policy. So just like last semester, we got to wear masks, we got to stay spaced. If you have exposure to somebody who tests positive for COVID, or if you or someone you're in close contact with has symptoms, please don't come to campus. There's a Zoom link in Moodle for all of the lectures for this class. You can attend online with no penalty. There's going to be a couple of hands-on things. I've got a project I want us to do this semester that it will be harder if you can't come in person. But if you have, COVID reasons, there will not be a penalty if you can't be in class. And then the other announcement is this screening requirement. Did everybody get the email from ISU about having to do a screening to be in-person classes? No? Okay. So there's a required screening program for anybody who's going to be attending in-person classes. You have to go spit in a vial and let ISU test you for COVID antibodies. I mean, I had a very classy spit. You maybe can drool.
It was awkward because I spit in it and it sat at the top.
Yeah, I had to pick the little funnel up to remove the suction. Yeah, if you guys can do the drive-through and not have someone watch you spit in the vial, I highly recommend the drive-through appointment.
I didn't have anyone watch me.
No?
I was able to spit in private.
Excellent. I think it'd be super awkward to have someone watch you try and spit in that. But it's just right across the street at the gym. And you have to do one screening between now and the 14th. And you have to do another screening from the 14th until I don't know when they're going to end it because they had to delay this screening a couple days. They were supposed to start earlier last week. You have to do both screenings, one in each time window, in order to attend classes in person. So you should have an email with a link to where you can sign up. So if you haven't seen that email, check your email. And then there's, hold that.
It's alive.
Okay. So our textbook is that nuclear thermal hydraulics book again. And as we found out last semester, it has some errors and typos. So I have an ongoing extra credit here. In any of the assigned reading, if you guys find a typo and you write up and tell me what page it is and what the error is and what it's supposed to say, I'll give you extra credit. And then we can start letting everyone know when we find these. Because I still think it has a lot of good information. We just obviously have figured out some of the equations, some of the practice problems, and just some of the wording has errors. And I had the bookstore notify the publisher and ask if they would do an errata, but they don't think that's very likely. So we're just going to make our own. So just as a heads up, we know there's some errors. If you find them during the course of the class and you post it in here, I'll give you guys extra credit on your homework for finding the problems. Okay. Any questions on that stuff so far? Yeah, Kyle.
Does it have to involve what we're learning at the time?
It has to be from the assigned reading. And Sam, did that answer your questions on doing the attendance in Moodle? Okay, awesome. And awesome, that's great, Sam. Okay, let's talk about the syllabus for a minute. Okay, so this class is going to talk about some things from a very non-nuclear perspective, even though we're still going to have some nuclear throughout. We're going to talk about boilers. We're going to talk about industrial boilers with really very little reference to nuclear systems. For the mechanical students, that's great. You will probably be around boilers in whatever job you end up. For the nuke students, a lot of times we have boiler systems at our plants that provide supplemental heat. And so it may be completely separate from any of the nuclear stuff that you have the system. So we're going to learn those complete systems as an entity. We're going to talk about steam generation and turbines. We're going to talk about operating our steam generators, our pressurizers, our heat exchangers. We will discuss very specifically some of the issues with these pieces of equipment installed in a nuclear power plant, but we're also going to be general enough that, especially for the mechanicals who maybe aren't thinking they want to work at a nuclear facility, you're going to get that good general information as well. So it's a little bit odd combining the mechanical and the nuke because we will have some very specific nuclear plant issues because we can have radioactive steam that the mechanicals would not see anywhere else in any other type of facility, but we're going to talk about both. It's a required course for graduation, which means you have to get a C-. Okay, we do have that nuclear thermal hydraulics. You can have the e-text or the physical text. We are going to have some questions out of it, some assigned reading from it. And then you need access to Moodle. Electronic devices, same as last semester. Whatever device you guys are using to either do attendance, pull up notes, look at course material, that's fine. If you're looking at non-class related stuff and a student complains because it's distracting or I notice, you will be counted as absent for that day. So use your electronic devices if you need to and want to, but use it responsibly. Okay. If you have a disability or want an accommodation from the university, I suggest that you get that set up early in the semester so that, you know, if you don't want to use it and it doesn't bother you throughout the semester, that's fine. But if you end up having some issues later in the semester, it's already in place if you want to start taking advantage of those accommodations. So there's the link if you need to work on that. In your STEC handbook, you have a copy of the ISU Code of Conduct. We'll use those standards in this course. I said this in the class earlier this morning, but just to reiterate, a lot of my rubrics, if you guys have a written assignment, they don't necessarily spell out that you need to cite sources, but not citing sources, especially in a technical field, is plagiarism. So it's a given that if you quote or reference some other work, if you have some sort of manual that talks about maintenance requirements and a question I ask, you refer to that, cite it. Even if the rubric doesn't explicitly say that, that's an expectation whenever we reference other people's work. Okay, here's our list of topics. We're going to start out with talking about boilers, and then we're going to talk about steam generation. There'll be a little bit of review of some of the stuff from thermo from last semester, and then we'll talk about steam generators, and that'll take us to the midterm. And then we're going to talk about pressurizers, turbines, heat exchangers, our heat generation and rejection systems, so cooling ponds, cooling towers. And then we're going to talk about steam supply accidents. And then in the last 2 weeks, we're going to have student presentations. So I'll give you guys some reminders throughout the semester as we start working on these. But if in one of these topics there's something that really interests you, be aware and be thinking about the fact that at the end of the semester, you guys are each going to have a short presentation to give on a topic covered in this class. Graduation will be before spring break, but after you walk at graduation, if you choose to walk, you will then still have to go and complete your online finals after spring break. Otherwise, they will not send you your diploma. So just be aware, it's kind of a little bit weird for a spring semester where we'll have graduation, spring break, then finals. Finals will be all online, and you can take them. It'll be like last semester. You'll have a time limit, but you can take them anytime within that week until they're due. Okay. Course requirements. Part of your grade will be attendance. Part of your grade is going to be the quizzes and assignments in Moodle. This class, a big portion of the grade is going to be that presentation. I want you guys to take something you've learned, delve further into it, present it back to the class. And then the other half of the class will be the midterm and final exam. We will do the midterm in class. You can have a one-sided crib sheet. And then, of course, the final will be online during finals week. And I use the standard grading scheme. You do have to have a C- in this class to graduate as tech. Any questions? Yeah.
When's that spring break?
It is the week of April. Let me look here. 26th. I think also if you look in Moodle, I have the dates for that week.
When did I have that? In March.
No, they changed it.
Yeah, they changed it. So it's going to work a lot like last semester, yeah. So spring break is April 26th through May 2nd. So like we had that Thanksgiving break, and then you didn't come back to campus, and then you did online finals the week after Thanksgiving. They're doing the exact same thing so that we don't have students who travel someplace where you have a lot more instance of COVID and then want to come back to campus and take in-person finals, and like you'd have to be quarantining. So they're just going to make everybody do online finals just to deal with the fact that we may still have issues with COVID in May. So yeah, April 26th through May 2nd is spring break. And graduation is April 24th. Okay. All right, any questions online? Okay,
Actually, I have a question.
absolutely.
That test that we're supposed to take for Johnny,
Yes.
when are we doing that?
Johnny told me in our back to school staff meeting that he was going to send you guys an email and ask you to pick between a few dates, what's the most convenient to schedule it. He sent you one before classes resumed, and he's going to send it again on Friday once everyone's like back on campus and remembers their passwords and can log back in and stuff. So the date has not been set. Johnny's going to ask you what dates work for you guys.
If you talk to him, can you have him send us the links and practice?
Yes. He's going to send that out again on Friday when he resends the whole email. So I don't know, did the mechanicals, did you guys complete that test, or do you have to take it again? Okay. Yeah, electronics test. You have to take it again, or take it for the first time? Okay. Okay. So I assume that Johnny will send you guys the email too, but I also assume that Evan's going to take care of making sure you're aware of what you got to do. I don't know if they'll have it all at the same time or if they'll have the nukes and mechanicals take it separate. Okay. Let's look a little bit at some of the assignments we have. So most weeks there is a reading quiz. They're due midnight on Sunday of the week we're talking about that topic. So we're talking about that topic, take the quiz that week. You have through Sunday at midnight to take it each week. We have some homework sets, which are going to be a lot of calculation problems. So if you go in here, right, so answers to the following problems from the Masterson text, okay? So there's the chapter and the page they start on and which questions. Some are short answer, some are calculations. When I was grading last semester's thermo classes and a couple of the others that had some more calculations, especially on the exams, there were some times on submissions that I struggled to know what you thought your final answer was. So circle your final answer. Sometimes people didn't finish the problem, so there wasn't a final answer circled, and that's fine. Sometimes that happens. But if you want me to know that you finished and you have something you think is the final answer, circle it. Because if it's not clear to me and you don't have it circled, like I might just take points off because I think you didn't finish the problem. So just to make sure there's not confusion and I'm giving you guys as many points as I can, circle final answers and calculations for me. And I try to remind you of that each time on each assignment. The homework sets are not due every single week. Sometimes, like the boilers ones, it's for all of the class sessions where we're talking about boilers. I really recommend that you don't wait until the last minute, that you start looking at a couple of these right away, both so that you can look at, hey, this is what is in the homework, this is what I need to be listening to when we talk about it in class, when we do an example in class, I need to make sure I have good notes. And then also so that, you know, that weekend before this is due, you don't realize that some of these are maybe more difficult than you had anticipated, because I will not do every single type of problem in class. Some of it is I do want to see you guys putting concepts together. There are a lot of examples in the book. There are a lot that we will do in class. And then on every set, there should be a couple that you haven't seen necessarily spelled out for you. And I'm looking for you to kind of put stuff together. So they're not supposed to be super hard, but they're definitely not start the day before they're due easy, if that makes sense. And then, like I said, we will sign slots for the presentations for those last 2 weeks. Since we're going to be presenting over 2 weeks, so everyone gets their time, to make things fair, what I prefer to do is your presentation file is all due at the same time. So even if you sign up for the very last presentation, that doesn't mean you get 2 more weeks than everyone else to work on your presentation. They're all due at the same time, and then you just present in the order you sign up for a presentation slot. So there's a rubric and instructions, and we'll talk about those more in depth after the midterms, because that's about when I would think you need to start prepping to have what you want as a presentation. But the instructions and the rubric are up. Okay. Any questions about the assignments, course format, layout, syllabus? Okay. Any questions online? Okay. Okay. So we're going to talk about boiler systems. We're going to talk about essentially the boiler system is what coal plants use to produce their electricity, just like a nuclear reactor has the fuel inside a pressure vessel. That's our equivalent to a boiler. But first, because a lot of our discussion will be for very specific power plant systems, I want to introduce a couple concepts as we compare coal and nuclear, which will be the two primary energy systems we talk about in this class in plants. Capacity factor and baseload power. Have you guys heard the term capacity factor before? Nope, nobody has? Okay. So capacity factor is a way of quantifying the maximum amount of power that we can get based on how a particular plant operates. So there's the rated power of the plant. Does anyone know typically what a reactor unit is rated for?
Like,
Around 990 megawatts?
It's about 2,000. Modern ones. Some older ones were smaller. 500, I think, is the smallest commercial one. About 2,000 megawatts. Does anyone know what a coal plant's rated for typically? 30? Is that just a guess? Yeah. Okay. It's not 30, but it is between 2 and 5. So it is bigger. I'm sorry. Okay. So coal plants are usually rated for a little bit more output. So you have how much you could theoretically make if your power plant was online at 100% power 100% of the time. How often do you think we are at 100% power?
30%.
30% for coal or nuclear? Nuclear is 30.
5 to 10% of all.
5 to 10 for both. So for nuclear, this is the data from 2017. 93.5% of the time, the nuclear generation in the United States was producing full power. And this is over all the plants. It's not any single plant, though most plants hit about 85 to 90. Some hit more. Natural gas was second, 57%. Coal is just under. And then hydropower is about 40. You what?
I said, isn't the hydropower just because they're holding water back from the farmers and the dams?
And also because hydropower, different times of the year, you can have more or less production that you're actually able to make. So when they say that they can produce however many megawatts, say you've got a plant that can produce 500 megawatts, well, maybe it can produce 500 in the spring, but it can only produce 400 in the fall. So even if it was producing all 400 all fall, that still affects capacity factor, right?
And is that like the 2,000 megawatts per hour, or is that megawatts per day?
2,000 megawatts per hour is usually what we're looking at. It's a lot, yeah. Coal, nuclear, and natural gas with these higher capacity factors. This is typically what we call base load power. So there's a certain amount of electricity that we need in the United States to just exist with the economy and infrastructure that we have. And that's our base load. Sometimes we need more, right? When people wake up in the morning and everyone turns on their radio and their shower and their coffee pot, all of a sudden we have a surge, right? And because we typically work very similar work schedules for most adults in the United States, there's a specific number of hours that that morning surge occurs. Then we leave our house, we turn everything off, we go to work. You're going to use whatever base load it is to keep that work building running. And then you're going to go back home, and everyone's all of a sudden going to have a surge of power when they turn on their oven, turn on their TV, and turn their air conditioning or their heat up, whatever you do when you get home, right? Base load power has to be available basically all of the time so that we don't have rolling blackouts, which the United States is not very tolerant of, unless you live in California. Then they periodically have that in the summer. But yeah, and their big problem is that they've switched over to so many of these non-baseload power sources. They have really embraced solar, which about a quarter of the time you can get power from, or wind, about a third of the time you can get power from. That when it's super hot in California in the summer and everyone wants to go home and turn on their air conditioners, they don't have enough baseload power to handle that load. So when we're talking about types of energy and types of power systems and how we're going to put energy on the grid, we're talking about very different things when we talk about base load and when we talk about load following. Some places like Idaho, our hydropower is actually part of our base load power. Actually, part of the reason our power here is so cheap, because we did all the spending money to build our dams before, and now we're just maintaining them, and we've maxed how much hydropower we can take out of Idaho, but we're not having to build new plants. We're utilizing those dams. So it's usually a very cheap source of power, but it's limited. And some places you go, it will be considered base load. Some places it's considered load following. Wind and solar can have really great applications in our energy grid, because when you're getting wind to blow and when the sun is shining, we're picking up extra energy without having to do a whole lot. Because solar is typically coupled with batteries, we're able to add that energy without a lot of the big traditional steam plants that we have when we look at our natural gas, coal, and nuclear plants. So it's just a slightly different form that we're getting that energy. And if the sun is shining, we might as well take advantage of it, right? So these can be great. They've got their problems, but they can be great. They're just not baseload power. When we talk about baseload power, pretty much we're going to be talking about these three. And even natural gas kind of depends geographically where you are. Coal and nuclear are basically everywhere, so you'll see a lot less nuclear in the desert. Coal is everywhere. So when we're comparing these capacity factors, pretty clear that when we want to produce energy all the time to meet our basic level of energy requirements in the United States, nuclear is far superior. Why? What are some of the things you guys can think of that would make such a difference between nuclear, coal, and then solar?
The natural happenings of the earth.
Fast.
Okay. Natural, fast, okay.
It's just harder to start up and shut down.
So that is a huge issue with baseload power. Once we get these going, we're getting to very high temperatures. We're getting to very high pressures. Starting that up, these plants, takes a long time. Shutting those plants down, dealing with the residual heat, depressurizing our systems, takes a long time. None of these move quickly, which is why we don't typically do what's called load following with our baseload power. We talked about, the morning when you wake up before you go to work, and then when you get home in the evening, there's that load that increases, there's demand, right? A little bit coal, but a lot more of these types of energies can supplement that load following. They're working on new modern plants for gas and coal that can load follow. And there's the hope that small modular reactors can load follow. But right now, our big, heavy, slow nuclear power plants, they produce all of their energy as much as they can, nearly all the time, but they're not going to change that output. So if all of a sudden everyone goes to work and less people need energy in their houses and your need decreases by 1,000 megawatts, you're not going to take that reactor to 50% power. You're going to keep operating at 100% power. And when you have people get home and now you need more than your 2,000 megawatts, you're going to use some other source to help give that. So one of the big reasons coal and natural gas are so far behind nuclear in capacity factor is that even though they're not very agile at coming up and down in power, they are way, way more agile than nuclear. So we can choose to reduce the output in our coal and natural gas plant a lot easier than we could in our nuclear plant. So we will. So they could reach capacity factors close to 90% as well. We could operate them that way. But what our electrical grid tends to do, that nuclear power plant is on 100% power as much of the time as possible. And then we'll plan to start these up in the morning before people have demand, taper them off a little bit in the middle of the day, bring them back up for the evening, and then taper them off at night. And we'll plan those very specific power movements. And then if we have a little bit more sporadic use, we'll use something that's a little bit easier to manipulate for that load following. Does that make sense? So when we talk about capacity factors and baseload power, can you guys see this image really well? Should I try and make that bigger?
Bigger, better.
See if we can. Okay. So this is kind of that image I was trying to describe with the baseload power. Nuclear, always going to be on, right? And it kind of gives you this time frame, right? So you're going to have an increase as people start waking up, they go about their day, and then when they go to bed, right? You're going to have, when we're active and up, we use more resources. That baseload power, it might provide more energy than we need, but we're still not going to turn our nuclear power plants down. They're going to fill up as much of this baseload as possible. Then our intermediate resources is going to be coal and natural gas. So sometimes places that don't have a nuclear reactor will have their coal plants provide the baseload. But they're a little bit easier to maneuver. And so they're going to provide this, and this is going to be on, in the morning we'll turn on, we'll provide this amount, you might come down in the evening. Then your peaking resources are going to be things that can respond quickly. Smaller coal plants, we're hoping the small modular reactors can provide this for the grid so that you can meet this need that's a short time, short demand, but still a large demand. Does that make sense? Okay. We're gonna look at this little link I have here. Okay. So this article that I got this image from talks about baseload power, right? We have to have that. So we can look at all the alternative energy we want, but if we can't get to capacity factors close to 90 for the baseload power we always need, they're not going to work for our electrical grid, right? We have to be able to produce that steam and produce that electricity, or else it's not a viable electricity source. One of the things that people who are very, very supportive of wind and solar are looking to do is they want to change how we calculate capacity factors and how we define our baseload so that solar and wind would be more viable in that sphere, right? Nuclear gets a ton of money and a ton of support, because we can't really match that capacity factor with any of our currently operating plants. Coal, I think, is always going to be a necessary component of the grid because it is able to hit that intermediate range so well. It's more flexible than nuclear, but it's way more stable for baseload power than our other alternative energies. So when we're using these energy sources, we've got these steam plants, whether they're nuclear or coal, we look at how often they produce their maximum energy, and that's how we get our capacity factor, right? So if you are able to produce 100% of your energy 70% of the time, your capacity factor is 70%. If you can produce 50% of your energy 100% of the time, the capacity factor is 50%, right? So how often you can produce 100% power. So one of the things that solar wants to do is they want to look at it and they want to say, okay, well, we can only produce about 25% of the time, but what if we could store our power in a battery so it's still available when you need it, even if the sun is not shining and our source is not at 100%. And so they want, this article kind of has a discussion on some of the ways that people who are real advocates for alternative energies like solar and wind want to change how the energy department thinks about capacity factor and baseload power. And I feel like this discussion is really important, one, because I think it's going to open up new opportunities in the energy field. And I think that as we see batteries, for example, increase in prevalence and ability to be used, we're going to see more options just in general for what baseload power can be. But also, as operators, when you're getting pressure to keep a system functioning so that it can run all of the time at 100% power, that's because the thing that drives a lot of the usefulness for a power plant on the grid is that capacity factor. If nuclear dropped down to a 50% capacity factor, I think with the objections that a lot of the public has for nuclear waste, we would not see power plants being built in the United States. We would be building coal. The fact that we can get such a high capacity factor with nuclear is what makes it economically feasible and environmentally responsible and desirable for our grid, right? The fact that coal and natural gas can be operated in a way that we can make up for some of that peaking in the intermediate range is why we can't get rid of coal plants, even if you think that they're not very environmentally responsible, or you think that there are other better sources, like right now, that is the purpose that coal and natural gas serve. We haven't replaced it. So as we start to discuss all of the components of our steam supply systems and how they help us produce that electricity and keep those systems running, be aware that the big responsibility on you and operators is going to be that these systems need to be operating 100% of the time. And so understanding where each one fits, what our maintenance requirements, how it helps this overall process is my goal for you in this class, and also why it's important overall in that career perspective, because those plants have to operate when we need them to, or else we're not contributing to the need we have for the electrical grid. Does that make sense? You guys have any questions? Yeah.
What would stop coal from banking their energy as well, like wind or solar?
In batteries?
It do become more viable.
So the biggest thing is that right now, batteries require so much energy production to produce that we don't have the kind of battery sizes and reliability that we need without putting more power into making them than they produce. The same is actually true of solar cells. So right now, the energy it requires to produce a solar cell is more than the energy that solar cell can produce in its life. So right now, they're not efficient enough, right?
Well, assuming that it was efficient, I mean, you have more than 50% of the coal to tap into. What's to stop them? I mean, the amount of megawatts they can produce is going to trump everything else.
And theory-wise, nothing, right? So if we have a perfect battery that we get to at some point, and we can store that power, like all of our power sources, nuclear or coal, we could operate them for a certain amount of time, fill the batteries, and shut them down. And we would need less operators to run batteries than we do the running systems, right? So it could potentially also be cheaper because we're going to reduce our workforce. The biggest thing right now that has us not doing that is that it is cheaper and more efficient to run the plants because we don't have that battery technology. And I don't see a huge drive towards battery coupled nuclear or coal systems, except for emergency backup cooling power for the plant itself. So ATR at the INL just put in a battery backed emergency cooling system. And so when they lose offsite power and they need to shut down their reactor and then deal with that residual heat, they have a battery pack that does that. It used to be that diesel generators were the standard, and they still are the standard commercially. But we're seeing some move towards that battery technology being coupled with coal and nuclear. But that's because they can have those batteries continuously charging from a small amount of the energy generated by the nuclear power plant. And it's not to store it for the grid, it's to store it just for the plant. So I think the biggest thing are the size of the batteries that would be required, their storage capacity, and their efficiency. We're just not there where it makes more sense than just continuing to operate the plant. But technically, we could decide to go that way. Maybe we make an amazing jump in battery technology in the next 10 years, and everyone's like, oh, we just want to fill up batteries and like go from there. And batteries just sitting there charged produce less carbon emissions, right? Like it could be the way we go. It just is not, the technology isn't there right now. Does that answer your question? Joe, did you have a question?
Baseload power, the amount of power normally needed. And capacity factor is that the percentage of the time that baseload power is achieved? Or is it different?
No, capacity factor is the percentage of the time you're at full power for an individual plant. So this sheet right here, for all the nuclear power plants in the United States, how often are they at 100% power? 93.5% of the time. For natural gas, it's 56.8. That might be because 70% of the time, natural gas plants operate at 70% power, right? And then they have a little bit before, above and below. Nuclear, it's because they operate at 100% power except for the month outage you have every 2 years where we refuel, right? And that's pretty much what nuclear plants try to do. So it's the percentage of time you're at 100% full power, and that capacity factor can be lowered by operating at lower power or by being shut down. Did someone over here have a question? Yeah.
I was just wondering if it also becomes a conflict with batteries converting everything from AC to DC or that. Because if it goes into a battery, then to go back out on the grid, don't you have to throw it back into the generator pretty much to convert it back into AC?
The way our grid is set up from a power plant, yes, you would have to. The battery-backed emergency system I was talking about, you don't have to do that because, right, it's just providing power to those systems there. I think that honestly, if our grid went that direction, that would not be a very hard thing to overcome. It's just not worth it right now because the batteries aren't good enough. So it might provide an extra step, but as we look at exactly how many steps of machinery are in our steam cycles, like to have a battery and a generator is still less overall in the system.
Yeah.
So I don't think it's a huge barrier if we, got amazing batteries. Any other questions? Online, you guys have any questions? Okay. Well, that's all I have today, so we'll knock off 5 minutes early, and I'll see you guys on Wednesday.
Our capstone classes in here.
No, it's over in the TNT building.
What room is it?
Let me look.
Burn the coal.
$317.
317, okay.
I wrote down the nuclear plant is 2,000 megawatts per hour, correct? But I didn't get what the figure was that you said for the coal.
Coal for,
Coal
2 to 5,
2 to 5
okay, so 5,000 megawatts.
megawatts.
Yeah.
So, I mean,